The equilibrium constant is sort of like rate constant. Rate constant is a constant at the same temperature, but if you change the temperature, the rate constant K changes. In the case of this, I'll give you a hint. So let's just say that this reaction is exothermic, so we add heat. So if you increase the temperature of this reaction, in which direction does the reaction shift? Toward the reactant side. So if you increase the temperature and you get more reactants, how is that going to change KEQ? Okay, so for an exothermic reaction, okay, so as the temperature increases, what's going to happen to KEQ? Is going to increase or decrease? It should. Who says it should increase? Who says it stays the same? Who says it should decrease? Yes, it should decrease. If you have an endothermic reaction, okay, so as the temperature increases, that means that the KEQ should so should the arrow be pointing up or pointing down?
Pointing up.
It should be pointing up. Okay, so I know we just have a few minutes left. Now we're going to start this electrochemistry lab today. But let's go back and let's look at let's look at this. Some of the equilibrium stuff. Yes, we spent a little bit of time talking about these buffers. So let's actually go back to these titration curves. Okay, so we talked about strong acids and strong bases, and we looked at titration curves. So there may be a titration curve question on the exam. So you know how to calculate pH at the starting point, the pH at halfway point, or different halfway points, and the pH at the end point. Okay, so there's equilibrium calculations involved there. So this is for, now this curve here, is this a monoprotic, diprotic, or triprotic acid? That's a monoprotic. And note that we also use this Henderson-Hasselbalch equation, pH equals pKa equals the log of the base divided by the acid. Okay, so there's another one. So we looked at those formulas. Let's see, we looked at heat drowning, we looked at, so this is one of the labs that we did. We made a buffer. Now, which equation did you use to make a buffer? Yeah, so you guys used that Henderson-Hasselbalch equation, which is this equation here. Yeah, this equation here. So we use this equation to make a buffer. So note that this is the buffer region here. And what was that general rule that we used? So to decide which acid and conjugate base to use, it's got to be the buffer pH should be near the pKa plus or minus 2. Okay. And what does pKa represent? Yeah, so whenever you see this P, like pH or POH, or pKa, it means that's the minus log of that quantity. Okay, so if you look up Ka, then you can calculate pKa. Okay, so let's see. And then we spent some time looking at polyprotic acids and bases for titration curves. And then you brought some MSG to lab and you measured the titration curve of MSG. then we spent a little bit of time on these blood buffers, baking soda. And then we looked at the second blood buffer system, which was the hemoglobin one. So there could be a question on either on one of those blood buffer systems. Okay, so note that, for example, in hemoglobin, how many acids and bases are present in our blood? Based on the picture here. How many acids and bases are present in our blood? May I just ask this question? How many acids are present in our blood? There should be two. What are the two? Yeah, so here's one, HHGB. The second acid is HHGBO2. How many bases are present? Yeah, two. So note that there's a total of 4 acids and bases present in the blood. And for example, we talked about which acid is, or which substance, which form of hemoglobin is present in our lungs, and we said it was. It was actually HHGB, because note that when this HHGB binds to O2, what happens? It forms, the HHGBO2. And then since the pH of blood is about 7.4, once the HHGB forms, it's going to form, anyway, it goes around this little circle. Okay, so there could be a question on this one, or it could be a question on these blood buffers. Okay, so we talked about these, about the blood buffer system. And then let's see, we spent some time, we got to the thermodynamics. I don't think I'll ask any questions. There could be a question on this. For example, we know how to dissolve insoluble compounds. Okay, so one way to do that is by looking at these equilibrium reactions. Okay, so for example, if you have magnesium carbonate, what substance would you use to dissolve magnesium carbonate? Would you use a base? Okay, you don't use, you use acid. Note that MgCO3, which is this one here, forms Mg2 plus CO3 2 minus. So if you had an acid, what is the acid reacting with? It's reacting with the carbonate, the CO3 2 minus, which is removing the CO3 2 minus, which shifts the reaction toward the product side. Yes, we looked at that, and then I don't think I'll ask any questions on these complex ions. We looked at, did anyone go swimming over the spring break after we talked about swimming pool chemistry? Okay. And then for thermodynamics, we talked about fuels and heat engines and refrigerators. So there could be a question related to fuels and heat engines and refrigerators. And then in lab, let's see, you looked at the energy content in foods. So there could be a question related to the energy content in food on the exam. Okay, so I'll see you guys in lab either at 11 o'clock or 2 o'clock.